or join. NDHKX, and that just is helpful to have that PowerPoint shown right to your screen. Okay, so we're going to learn about the graph of tangent, y equals tangent x, and we're going to graph variations of y equals tangent x, and cotangent, and y equals cotangent, and then cosecant, secant, cosecant, and variations of those. So, the most important part of this section is the first 4 points. The first 4 points. While graphing cosecant and secant's important, it's not as important as the first 4. You will not be tested on the last 2 points. So, in order to, we may kind of be skipping some of that and letting you look at the filled-in notes for those last 2 points. But the most important is the first 4 points. All right, so this is the graph of tangent x. And I'm going to show you, there you can see they've actually just put it in their calculator. But let's use the unit circle. This is an additional page, and I don't know, I think I have it actually posted. Section 4.6. Let's use the unit circle. To find tangent theta at the 5 key points. Now it has different 5 key points than sine and cosine, because the period of tangent is pi. So you're going to take pi divided by 4. That's what you're going to add. So we got to go by pi over 4. Here's our unit circle. So we're going to start here, and we're going to actually start at, this is going to be minus pi over 2, and then this is going to be minus pi over 4, and this is 0, and then this is pi over 4, and then up here is pi over 2. So those are the angles. Minus pi, these are the 5 key points. Because it's we're going to start down here, and we're going to use minus pi over 2, and then this next one, and the next one, and the next one, and the next one, and then tangent repeats. So this takes care of, this is the period divided by 4, and this is just tangent of theta. So we're going to start, our x1 is going to be 0. No, not 0. Minus pi over 2. So we got theta and tangent theta. This is one complete cycle, and what happens at minus pi over 2, let's write down the coordinates. This is 0 minus 1, cosine sine. And this is the square root of 2 over 2, comma, square root of 2 over 2. And this is 1, 0. And this is square root of, oh, wait a minute, there's a negative sign somewhere. Negative down there. This is square root of 2 over square root over 2. No negative sign. And this is 0 to 1. So we're going to start with, for tangent, we're going to start with x1 equals minus pi over 2. And tangent is sine over cosine. So this is cosine and this is sine on a unit circle. That's cosine, this is sine. So at minus pi over 2 we have minus 1 over 0 and it's undefined. It's actually a vertical asymptote. VA. Okay? And then we're going to add pi over 4. So at our next x2 for tangent is going to be negative pi over 4. We're going from this and adding pi over 4. And then that's the square. This is the square root of 2 over 2 divided by negative square root of 2 over 2. And that's negative 1. I mean, it's kind of hard to see. You're dividing something by itself, but you have a negative sign, so you're going to get negative 1. Okay? And then the next point is x3. You would add pi over 4 to this, and you get 0. So it works the same way. You have to take the period divided by 4 and add it to each one. But this is what we start with. Minus pi over 2, we go to minus pi over 4, 0. And at 0, sine is 0 and cosine is 1, so you get 0. And x4 is going to be pi over 4. If we want to give ourselves some more room and actually write sine square root of 2 over 2 divided by cosine, and that equals 1. Anything over itself equals 1. And then you add another pi over 4, and you get x pi is pi over 2. And then sine is 1 there, and cosine is 0. It's undefined. That's another vertical asymptote. So that's it, and we can graph it. So this is how we graph it using the unit circle. Using that y over x, you know. So here's the graph. This is pi over 4. This is pi over 2. Minus pi over 4. And this is minus pi over 2. This is 1, and this is negative 1. And these are vertical asymptotes, so you can draw them with dashed lines. And I'm going to draw it in blue, I guess, just to. So we've got the points minus pi over 2, minus 1. Oh, that's right here. I don't know if that's the right spot. So 1, and pi over 4, 1, and 0, 0. And it goes like this. So that's the graph of tangent theta. We can use, and you could do the same thing for cotangent, but you just flip it. So cotangent, though, is going to start, we're going to start with 0 on it. Well, we'll start with tangent here. So there's tangent. And it says tangent is an odd function on your slide, so are we done copying that? Or did I have that posted? I think I did. Okay, great. So tangent properties period, the period is pi. It's an odd function, which means it's symmetric to the origin. The domain is all real numbers. It doesn't fit in here, except odd multiples of pi over 2. So it's all real except, so in this class we don't have to use interval notation so much. So we're going to say odd multiples of pi over 2. Okay, it's not just, and its range is minus infinity to infinity, or you could say all real numbers. So since it's an odd function, tangent of minus x will equal minus tangent of x. And sometimes we need to use that to simplify things. We don't want to work with the negative angles. We would always rewrite it if we had a negative angle. And the tangent function is undefined at pi over 2. And there are vertical asymptotes at odd multiples of pi over 2. And x-intercept occurs midway between each pair of consecutive asymptotes. So here's the graph of it. We graphed just one cycle right here. We've got this point, and this point. These are vertical asymptotes. At odd multiples of pi over 2. So yeah, it just repeats. I'll just draw a couple of these. You have it there. We could keep going. So each one is going to be here, here, and here, 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 and here, and then you're going to draw it like that with arrows on the end. And it keeps going. It keeps repeating. There's another one here. And there's another one here. Got it? So that's the tangent function. Okay, so here's the steps. So instead of doing the 5t, okay, well, here's more characteristics on slideshow. The period's pi, the domain is all real numbers except odd multiples, and the range is all real numbers. And again, so this is all the stuff we filled in: vertical asymptotes at odd multiples of pi over 2. And notice an x-intercept occurs midway between each pair of consecutive asymptotes. So we're going to use that. We're going to find the asymptote. And we're going to use the fact that points on the graph a quarter and 3/4 away between the consecutive asymptotes have y coordinates of -1 and 1 respectively. So that was not written down yet, was it? It's going to be written down. Oh, it's here. So the graph and its characteristics. So here's the step to graphing the tangent function. We're going to find the two consecutive, we want to find the two consecutive asymptotes, vertical asymptotes, by finding an interval containing one period. We do that by solving this inequality. We will solve minus pi over 2 less than bx minus c less than pi over 2. We will solve that for x. We'll add c and we'll divide by b. And therefore a pair of consecutive asymptotes occurs at bx minus c equals minus pi over 2 and pi over 2. These are where it occurs at, these are our x values, where the vertical asymptotes occur. It is not just a regular tangent x function. And then we're going to identify an x-intercept halfway between the vertical asymptotes, consecutive asymptotes. And then we're going to find a point 1/4 and 3/4 away between the consecutive asymptotes. These points have y coordinates of minus a and a respectively. It was 1 when we had an amplitude of 1, but now if we have an amplitude of a, that's how we do that. And then we use the above graphs to graph one full period and then add cycles to the left or right as needed. So, okay. So the next slide shows kind of a picture of that. We're going to solve bx minus c equals pi over 2 for x. That value of that line, that vertical line, x equals whatever it is, that will be one vertical asymptote. We're going to solve bx minus c equals minus pi over 2 to find the other one. And then halfway between there's an x-intercept, 1/4 between those asymptotes, where it's going to be down at negative a, and 3/4 between them from here to here will be at positive a. This is how we're going to graph tangent function. You'll have to memorize this. So guess what? You don't memorize a huge amount of stuff in this class. So write it down and practice. So we're going to graph y equals 3 tangent 2x. Okay, so I'm going to do this solution over down here, I think. It's just, so we're going to graph y equals 3 tangent 2x, and I'm writing down above it y equals a tangent of bx minus c, b greater than 0. So identify a, b, and c first. A is 3, b is 2, and c is 0. There's no phase shift. Because we're not going to start with phase shifts. It's confusion. Find two consecutive asymptotes. So what's the part in here? 2x. This part. That's why we're going to solve 2x less than minus pi over 2 between these two. On a regular tangent function, these are the vertical asymptotes. Now, with this one, with it being 2x inside of it, we need to put 2x there, and we're going to solve for x. Now we can either do that simultaneously by dividing by 2, and when you divide by a positive number, we can divide by 2 by multiplying by a half. We can do it all together, and that's where they got this magical number here. Or you could set these, so you get minus pi over 4 less than x less than pi over 4. And that's how they got the answer. The vertical asymptotes will be at minus pi over 4 and pi over 4. But you could also you could set 2x equal to this and solve that and find the lower one, and you could set 2x equal to that. These are the asymptotes. You got VA's vertical asymptote at x equals minus pi over 4 and x equals pi over 4. So minus pi over 4 and pi over 4 all right, now, so we got the 2 consecutive asymptotes. Now we're going to identify an x-intercept. Oh, wait a minute. So an interval containing 1 period is going to be from minus pi over 4 to pi over 4. There's not enough room here. And 2 consecutive asymptotes occur at minus pi over 4, pi over 4. Then we're going to identify an x-intercept midway between these 2 consecutive asymptotes. Well, that's at x equals 0. It's midway between pi over 4, minus pi over 4, or pi over 4. So the graph goes through the point 0, 0. So that's 1 point. Now you're going to find points. Now you're going to find points 1/4 and 3/4 of the way, and their y coordinates are minus pi over 8 and pi over 8, just halfway between 0 and minus pi over this minus pi over 8. This is pi over 8. A equals 3 for this problem, so the graph is going to pass through, it's actually at minus 3, minus pi over 8, and minus 3, and pi over 8, and positive 3. That's, the amplitude puts it up here at 3 instead of 1 and negative 1. Then we draw the curve. That's our function, and we drew 1 full period. And then if you wanted to graph more periods, you could continue. You would draw more. Okay, we'll talk about cotangent next time. So we will stop there. Thank you, guys.